Now it's time to assign rainfall to the project. So make sure you collapse your widgets and open the rain editor. You're going to check simulate rainfall, and this will be set to 2.65 inches because I'm running a 6-hour 100-year event. I am going to apply building rain, and don't worry about the rainfall abstraction. That will be assigned to a different group of data. So that stays at 0 at this point. Now, we need to add the storm pattern. So this goes to open, and if you want to be in Flow2D Pro documentation, and you should see rainfall distributions, and this is the 6-hour event. We'll just use the pattern, the first pattern. And you can see that that imported your data and updated your curve. So Flow2D data is time on the left of the table and percent discharge on, or sorry, not percent discharge, I'm sorry, percent cumulative rainfall on the right, but it doesn't go from 0 to 100%. It goes from 0 to 1. Okay, so very important. This goes from 0 to 1, and it has to start at 0 times 0% rainfall. So that's how that data works. It's pretty easy to create this data, but you can also get it from lots of other software. I think, you know, HMS, HEC1, HydroCAD can create these rainfall distribution curves, or you can create them yourself with your own, you know, statistical rainfall software. So that's how you set up uniform rainfall. So this will give you this 2.65 inches of rain on every grid element. When you run the project, it'll give it to you. Every grid element gets that same amount of rainfall using the same distribution curve. It's called rain on grid. So instead of applying it to like a unit, like a sub area of your watershed, you're applying it directly to the grid. And it's a small enough project that you could just probably apply it uniformly. It wouldn't make a difference. Now, if you have a larger project, you can add some spatial variability, but I'm going to show you my example is a 24-hour, so don't get confused by the fact that my rainfall raster is 24-hour. So I'm going to drag and drop that here, and then I'm going to see this is NOAA data from NOAA Atlas 14, 24-hour 100-year, but it's a little bit different because two things. NOAA Atlas data is not in this is just rainfall in inches, and NOAA Atlas is like, this would be divided by 1,000. So and the next different thing is if I zoom to this layer, I right click, zoom to layer, this is the data for the whole state of Arizona. So maybe it's put together by like Maricopa County, or maybe it's put together by the Arizona Department of Transportation and isolated, and it's in our coordinate system, and it's in units of inches, so you don't have to like convert it to use it. So rain on grid is going to work slightly differently. It's not going to be a depth area reduction, even though I know it says that. It's not really the case. It's more like a point depth reduction because it doesn't work the same way that a depth area reduction would work. And so it's a little bit different. So what you have here is, I'm going to start sampling this. Now remember, the total storm for the 6-hour event is 2.65, but the total storm for this one is 3.7 something. So if I hit ID on this and I start clicking around, you can see those variables change as I get on different pixels of this data. The pixels are about 1,000 by 1,000 feet. And you can see that that band is like the rainfall for that pixel. And if I zoom out a little, you can see those pixels more clearly. So the white pixels get higher rainfall than the dark pixels. Okay? So, And so if you have a large project with a large watershed, you can make an adjustment to your total rainfall by sampling those pixels to your grid. And that's what we're going to do. So of course, I would normally do this on the 6-hour pattern, but I'm going to show you what it does just so that you understand how it works. Okay, so I'm going to check the checkbox and sample the data. And so that is the correct raster. Remember, if you don't need to fill no data, it doesn't matter what this value is, and we don't need to fill no data. And then click OK and click yes. I already had some in there because I already did this. And now it's probing that raster. It's doing the same thing it did for your elevation calculation. Okay? So like an area weighted average of the pixels that intersect with each grid element. Let's look at what it exports. Okay, so let's export the .dat file. First, we need to show you that if you look at your Flow2D parameters, or your components, sorry, your control parameters, you'll see that the rainfall switch was turned on when we checked this checkbox. So we don't need to turn the rainfall switch on. And I'm going to click Save, and it's ready to export. So I click Import, Export DAT files, and this will go here. And we now see that rainfall no longer has an asterisk because it is now, the data is processed. And then we exported that to our export folder, and then we come back to our export folder, and you can see that we now have a rain.dat file. And if I think I already did this, but I'm going to check anyway. Well, okay, this is the data we've already looked at, and here's rain.dat. So let's just break this file down a little bit. So 0 means that we're using uniform rainfall. 1 means that we are going to run a rain on building. We'll talk about that in a different lesson. Total inches of rainfall. This means we're going to apply that point reduction. And this is, of course, that distribution curve. And all Flow2D data is space delimited, by the way. So these are not tabs, they're spaces. And this is grid element 1, and its point reduction factor is 0.999. So let me show you what it did. So this is grid element 1, and what it did. Now if I sample this using my ID tool from up here, if I sample this, it's going to show you that it says band 1 says 3.75. Now, but our factor was 0.999. So what it did was this raster was warped to match the grid shape and resolution. Then it took that new raster and it did statistic analysis on it to get the max, and then it's taking the point sample from the centroid and putting that over the max to get the ratio, and that is what becomes the depth point reduction, is this ratio. So it doesn't really matter what the units of this file is, just that it knows the max and it knows the local grid element rainfall total and the max, and then it can set up the reduction factor, and it's a depth. So that's why it's not a depth area reduction, it's more like a point reduction, because this is not like a uniform rainfall assigned to a subwatershed or a watershed or a HUC unit or something. Okay, this is rain on grid. That means each grid element gets this amount of rainfall reduced by whatever you calculate from here. And I think that's all I wanted to talk about for rainfall, so I'll stop the video now.